First of all, welcome everyone, and thanks a lot for taking the time to join this session. I'm here to talk about how we scale the front-end code base using Micro Frontends at Personio, with the hope that by the end of this presentation, all of you would have seen something new, or you would have some homework to do during your bedtime reading. Let me first formally introduce myself. My name is Swapnil. I work as a front-end engineer for Personio. I've been working with Personio for about 2 years now. I'm originally from India, and I moved to Munich back in 2019 April. And since then, I've been working with Personio from the Munich office. Let me quickly walk you through the agenda. First of all, I'm just going to give you some introduction about Personio, how the product and engineering department is structured, and the technology stack that we use, which will be relevant for the slides coming later. After that, we'll be getting into the juicy part of this presentation, which is scaling the front-end code base using Micro Frontends. And then I'll be briefly touching upon what will be the future of front-end at Personio. All right. So what is Personio? Personio is basically a complete HR solution for SMEs. And we have various verticals within the product, like the payroll vertical, employee development vertical, recruitment, and various verticals inside employee management. We started our office here in Munich back in 2015, where we started getting customers from within Germany. And then in the span of last 3 years, we've been gathering customers all across Europe. And right now, we are managing the data of approximately 1.5 million employees across Europe. All right, just a brief introduction about our product and engineering department. At the very top, we have product tribes, which are responsible for working in a certain vertical. And each tribe within itself has product teams where we engineers work in. At the very bottom, we also have a technology platform tribe. This includes infrastructure engineering, developer experience, security engineering, QA. And in the middle of this sandwich, the jam is the product platform tribe where I work in. This also has different product teams like identity access management, tasks, and workflow. And the one that I'm going to talk about in this presentation is the platform UI team. Moving on to the tech stack. On the micro frontends side, we use React.js. And in some micro frontends, we also have Redux, and this is all powered by TypeScript. On the monolith side, the backend is built in Laravel, which is a web framework for PHP, and the front end is a mix of React and jQuery. On the microservices side, most of our microservices are in Kotlin, but we do have a few microservices in Golang also. On a high level, this is how all these components interact with each other. At the very top, we have the monolith front end and a bunch of micro front ends. They all interact with the monolith as of now for getting data from the monolith or getting data from the microservice. So if there's the need of data for getting from the microservice, we still have to go through the monolith right now. All right, moving on to scaling the front-end code base using micro frontends. I have divided this section into 3 stages of evolution of code of like at Personio or frontend. But I'm going to briefly touch upon the first 2 stages because they are not really about micro frontends, and then I'm going to focus more on the third stage, which is about micro frontends. So before I start talking about these stages, there's this terminology that I want everyone to understand. You'll keep on seeing this on the slide. This is called Laravel blade templates. Blade templates are basically a combination of PHP and HTML. This is something that the Laravel framework provides us. A typical blade template looks like this. There'll be some HTML along with a bunch of PHP code. And then the Laravel templating engine takes this blade template, processes all the PHP inside this, and the output of this process is in HTML, which then goes to the browser. These blade templates can also inherit from each other. Like imagine if you have a web application with 3 pages, dashboard, profile, and payroll, you'll create specific blade templates for these pages. But imagine that you have some UI components which are common across all the pages. Let's say you have a top bar which is common across all the pages. What you can do is you can put that top bar inside a file called layout.blade.php and let the other page specific blade templates inherit for that from this particular blade template, so that you don't have to repeat the code all over the place. All right, this is all we need to know about blade templates. From here on, whenever I say blade or you see blade in the presentation, I mean Laravel blade templates. All right, so stage one, back in 2015, very simple web application which had a structure like this. We were using jQuery on the front end. We used to have like one jQuery file for each page. There used to be one blade template for that page, and then there would be a controller which was responsible for processing this blade template. And we had several pages like this, and everything was on the front end was either in blade templates or in jQuery, right? Then we wanted to introduce state-of-art technology. Of course, React came to our mind, and React was the winner. And this is how we integrated React in a nutshell. So we transformed all those JS files into React components. Not all the jQuery code was translated into React. Some was, but it was impossible to translate all of that. So basically, we ended up executing the jQuery code from within the React components. Then all of these React components were bundled into a single file. Let's call it bundle.js for the slide. And then this was injected into a blade template called layout blade template. And all the other blade templates that you saw on the previous slide started inheriting from this one blade template, so that they have the React.js code, which would then get executed on the browser front. So this is what the first two stages look like. At this point, we had React with us. We were pretty happy that we are using something which is pretty new. This was somewhere back in like 2017, right? So at this point, we had one monolith code base for the backend. For the front end, all the engineers were pushing on only one in this one code base. Let me walk you through how the deployment experience at that time used to look like. So we had this Slack channel called deployment queue. This was specifically for deployment, where engineers would add their names like this, and one by one you would deploy whatever you want to deploy. And we used to do this one by one, so that we have, if we have easier rollbacks, and it is easy to find out what is the problem on production. If like the website goes down, it'll be easier to identify which deployment broke the production. Because if everyone is deploying at the same time, it'll become a nightmare. So this is how stage two used to look like. Now, on one fine day, there was an announcement from the management that we are going to grow the engineering by 3x. And us engineers, we were happy because we're going to have more engineers around us. There'll be more conversations around technology. We'll get to learn so much from each other. But then this thought struck us. Hold on. What about the deployment queue, though? It'll become it won't be possible to manage this deployment queue if we have so many engineers working with us. Then one of the engineers were like, chill, bro. We have micro frontends. I've heard this term floating around on the internet. This will help us solve the problem of deployment queue. Actually, you will actually not have to go through the deployment queue at all, right? This left us perplexed because when he said this, it sounded really good, but we had no idea what a micro frontend is, right? So with that thought in head, let me go to the next slide and understand how a typical micro frontend setup would look like. Let's look at this example. Let's say that we were building an e-commerce website, right? Where we are showing a product over here. Then we also have a related product section. We also have this button over here, which shows the price of this product. And we also have this section over here, which is a basket. Let's say that on this page, 3 different product teams were working on. One was responsible for showing the product itself, its different variations, and some description about it. Let's call this team the product team. Then there was another team called checkout team, which was responsible for showing the price of the product and the state of the basket at this moment. Then there was a third team called Inspire team. This Inspire team was responsible for showing related products which are related to the product that you're viewing right now. Now you can imagine as the application grows, you'll have many pages like this where multiple teams could be working on the same page and responsible for different components on the UI to display them. Now, as the organization grows and you get more engineers, it becomes a nightmare to deploy a new feature or fix a burning bug on production because there's the deployment queue. You have to wait in the queue to get your chance, right? What if we could figure out a way to carve out all this code, which is responsible for each team, into different repositories, bundle them separately, and then enable them so that they can have their own independent deployments and they're not blocked by each other? How would that look like? So on the same page, it will look like something like this. The team A will be responsible for writing the code for the product section. Checkout team would write the code for all the stuff related to checkout, and the Inspire team would write only the code for the related product section. And they'll have separate bundles on working on this web page. They'll have separate repositories and separate deployments. This is basically what Micro Frontend in a nutshell looks like. So we learned all of this, and then we reached the third stage where we introduced our first Micro Frontend. In this diagram and the previous diagram, everything is same. Only we have a new component over here, the payroll Micro Frontend. This was the first Micro Frontend that we introduced in Personio back in 2018. Basically, created a new GitLab repository, a brand new React project, which would have like a separate bundle for itself, and we just injected that bundle inside that specific Blade template. We did this just because we wanted to experience or experiment with Micro Frontends and how it would work on production, and we were pretty satisfied. But it was not that easy to scale, like carve out all of these components, have separate Micro Frontends for separate teams, because Micro Frontends, they come with their own challenges. Now, in the next section, I'm going to talk about all of these challenges and how we tackle them over time. Talking about the first challenge, ensuring design consistency. Imagine that you have 50 pages on your web application and you have like 50 Micro Frontends running on production. Every team is owning their own Micro Frontend, and as the organization grows, it'll become impossible to maintain design consistency. Designers might get adventurous and do something crazy on a certain web page. Front-end engineers will start developing their components in different ways. There'll be no consistency within the code also, right? So with this in mind, we developed Personio design system. This screenshot is actually from production. You can actually go to this documentation. It is hosted at personio.design. This is basically a documentation, a central place with design guidelines and all the reusable components that engineers and product teams can use across Micro Frontends. So with a design system, we ensured design consistency across Micro Frontends and eventually across the application. This documentation also provided a live playground for engineers so that they can play around with the components before actually consuming them in the Micro Frontends, and like ahead of time think of additional features that they need in these projects. In these components. Now, this documentation also had design guidelines, so it was very helpful for designers to be aligned on the design guidelines in Personio, so that they don't build something crazy which looks out of the place in a different web page, right? So this wraps up the first challenge that we faced with design system and how we solved it. Moving on to second one, alerting on Micro Frontends. For alerting at Personio, we use Sentry. I'm not talking about the Sentry Marvel Universe character. I'm talking about the Sentry tool. Most of you would be familiar with this. So when we had the monolith, we used to have one Sentry project for frontend, and all the errors originating from all the pages used to go to this one particular project, right? Now, over time, as we grew, it became impossible to, for an engineer, let's say I'm working on one particular team, and my responsibility is to manage two pages on the Personio application. If I'm getting all the errors from all the pages in one project, it becomes a nightmare to understand which belongs to my domain. So what we ended up doing was create separate Sentry projects for each Micro Frontend and have this piece of code within the Micro Frontend, which basically creates a Sentry instance for that particular Micro Frontend, and any error originating from this Micro Frontend goes to a different Sentry project. Now this became with this, engineers were alerted very quickly when production broke, and the reaction time to bugs increased because now I don't have to go and filter through 50 different alerts on Sentry and figure out which one belongs to my domain, right? Moving on. So we had a problem with translations also. So as I told you, we started with Germany first, and then we expanded across various countries in Europe. We definitely wanted to have like multiple translations enabled on our product. So when we had the monolith at that time, we decided to use this tool called Phrase, which basically gives you a nice UI where you can like create a new translation, add translation for multiple languages, and also provide like a unique identifier to identify this particular translation. When we had the monolith, how we used to use these translations from Phrase was basically when you deploy the monolith, you pull the translations through an API provided by Phrase, and then this was basically a JSON, and then you just push this JSON into S3 bucket, and then on the browser you just get it from the CDN, right? But as we started doing micro frontends, there was a problem. We all were like editing the same translation file all the time. Even if we needed like 2 or 3 translations from the whole file, we had to download the whole file. There was no point of doing that, right? So there was a need to isolate translations for all micro frontends. So we ended up creating this tool called Translation Synchronization Tool. This was a separate project, and it has some scripts which are responsible for isolating the translations for micro frontends. In a nutshell, uh, it just pulls the translations from Phrase, segregates these translations into separate JSON files, and then pushes them to S3 in a way that one JSON file belongs to one micro frontend, right? And then on the browser side, let's say you are at the payroll page and there's a payroll micro frontend running over there. This micro frontend knows that my translations belong in the file called payroll.json. It'll just ping the CDN and get only that portion of whole translation. We don't have to like download the whole translation now. Now with this tool, we had a reduced size of translation files on each web page. There was no chance of translation key collision between two teams now because we have different translation files for each team. Now, we also didn't have to deploy the monolith just to push the translation to S3. This was like a small phase when we started doing micro frontends, where when we used to add a new translation, we used to deploy the micro frontend, and then we used to also deploy the monolith just to push the translations on S3. So this also we got rid of. Now, let me just quickly show you how this translation developer experience used to look like when you want to push something on production. All you have to do is go to a GitLab repository where you'll have this button called Run Pipeline. You just push this button. This button would then trigger all the scripts that are responsible for pulling and pushing the translations. And you also get like a nice UI over there, which shows you the diff of previous translation and the new translation that you're adding. And with this, we like carved out all the translation out of the monolith and have separate translations for each micro frontend. But just doing this was not enough. Like imagine that locally you are developing something, a new web page where you are adding a new translation. Now you see the designs and you become skeptical that maybe in English this looks fine, but what if in Spanish the translation is longer and the UI breaks, right? So you want to catch these problems ahead of time, which brings me to the local developer experience. So for that, we ended up creating another tool called Translation CLI, which runs locally. All this does is pulls translation from Phrase app, and then in the micro frontend we have a switch which decides whether to use this local translation serve or should we use the ones that are already on CDN. So with this, we were able to develop with real translations, and then we were able to catch like edge cases with long translations ahead of time before going to production. All right, this brings me to the fourth problem: a central registry for micro frontend asset identifiers. What do I mean by asset identifiers? So in a typical modern front-end application, we usually use a bundler. Let's say you're using Webpack, and the output from the build command is usually a bundled file, which has a name something like bundle.abc.js. Now this ABC part is what I mean by asset identifiers, because this ABC part keeps on changing as you build your application over time. So now our micro frontends were set up. All right, we needed a central place which could tell us that if you want the latest asset of this micro frontend, this is the unique asset identifier that you have to use, right? So we ended up creating an artifact service for this. This artifact service like works on the backend. It's very lightweight, and it has its own database, which is also very simple. Basically, a key value pair where the key is the name of the micro frontend and the value is the latest asset identifier ID. So, how did we used to utilize this artifact service? Basically, in every micro frontend's deployment pipeline, we ping the artifact service saying that, hey, there's a new deployment of this micro frontend going on, and these are the latest asset identifiers. And after the deployment pipeline is done, the artifact service already knows that there's a deployment and it knows what are the latest asset identifiers. Now with the artifact service, this is basically how a request used to look like. The request would go to the monolith backend, then the monolith backend would ping the artifact service asking for the asset identifiers. The artifact service would reply with that, and then the monolith would inject these micro frontend assets into the blade templates, and then the monolith would return back with the HTML to the browser. And now in the browser we have a script tag which is pointing to the latest assets of a particular micro frontend. Then coming to the second last problem, removing the overhead of bootstrapping new micro frontends. Now imagine that you have a vision that within the next 2 years, we want to have 20 micro frontends running on production. This causes another problem. Like imagine that as a front-end engineer, you have to create new micro frontends every 3-4 months, right? We'll have to create a whole new like React application, do all the bundling configurations, ESLint configurations, and whatnot. Of course, you can use a boilerplate, but then there's another problem that every team might start using a different boilerplate, and we won't have any consistency across micro frontends, right? So we ended up creating this another tool called Micro Frontend Generator. This micro frontend generator has all the API configurations, everything related to design system, like the packages that I was talking about earlier, build configurations, sentry configurations, lint configurations, any configurations related to translation, and all the deployment setup for a micro frontend. In order to use this tool, all you have to do is have this running locally for you. Run a command line. Run a command on your terminal, and this generates a brand new micro frontend with everything bootstrapped in it, so that you don't have to do anything for yourself. But there was just one more problem. Sorry. How do we provide updates to existing micro frontends? Like with this setup, of course, a brand new micro frontend can be created. But then what if, let's say in API configurations, you were using Axios and later on in time you realize that, hey, Axios is not really working for us. We need to move to a different technology. You cannot just tell all the front-end engineers to change all the code in their own micro frontend related to API configuration. You need a way to provide updates to these micro frontends. So we ended up carving out all of this into NPM packages. Like we have a request package for APIs. We have UI components, UI theme, which is for the design system. And then we have a specific Personio ESLint package containing all the linting configurations. And then we also ended up creating another project called DX Pipeline. DX means developer experience. Basically, all the pipeline setup related to micro frontends and microservices is inside this project. And within the deployment setup of a micro frontend, we just refer to these files in these repositories. During the deployment, it just fetches the content of those files and runs all the command which are present in these files. So with this setup, we had like a way to remove the overhead of bootstrapping new micro frontends. The last challenge in front of us was communication between micro frontends and between micro frontend and a monolith. Now imagine that you're working on a dashboard, right? You have a micro frontend, a section in the page, which is your team's micro frontend. There could be another section in the page, which is in the monolith. Basically, what you want to do is you want to click a button in your micro frontend, and you want to, let's say, show a pop-up which is in the monolith, right? Now, this is a different bundle. on the micro front end, and on the monolith we have a different bundle. They have no idea how to communicate with each other and how to invoke components from like event which is occurring in a different bundle, right? So for that, we did some research around what could be the possible solutions. First, we thought that maybe we can have a global Redux store and have some hack around these micro frontends, so that through the Redux store, we can dispatch events and tell these like have cross application communication. But we felt like this would be like abusing a state management library. This is not really what Redux is built for. Then we considered window.post message. This is also a possibility, and technically it is possible to use this as the communications channel. But then, considering best practices, it didn't feel like this is something that we should use, because window.post message is supposed to be used for cross origin communication, and we were working on like same origin here. We also consider having like an external dependency and event bus library, which would just run on the front end and serve the purpose of this cross app communication. But then we thought that do we really need an external dependency for that? Maybe there's something else out there which we haven't looked out. Then we turned to custom DOM events, and this turned out to be a perfect match. If you don't know about custom DOM events, it is exactly same how the other DOM events work, like on click or on change. All you have to do is invoke this custom DOM event from within your code, and it bubbles up through the DOM exactly like any other DOM event. So basically, what we did after we chose custom DOM events was we used to we started like triggering custom DOM events from within the micro frontend, and we used to have event listener on the monolith side, which would listen to these events and execute a callback whenever this event is triggered from somewhere. So with all this setup and with all this effort that we did, I want to show you how it helped us eventually. First of all, with this, we had autonomous product teams. What do I mean by that? So with micro frontends, microservices, and our own database layers within for the team. This is how typically like the structure of a team used to look started looking like. We have our own micro frontends, our own microservices, our own database layer. We're not dependent on any other team. And this happened, of course, across all the teams at Personio. Every team having their own micro frontend, their own microservices, and their own database. No one's blocking each other, right? And the combination of micro frontends and microservices gave us vertically scaling autonomous product teams, which are not blocking each other at all now. Also, empowered engineers. This is my animated version. Once we had all this setup ready, it was so easy to do stuff. Especially when I didn't have to go through the deployment queue to deploy my updates. We had independent translations for micro frontends. We had the design system to maintain design consistency and also have reusable components. There was no deployment queue anymore. We had alerting on our front end, and it was so easy for me to like go through the alerts which are belonging to my domain. And then we had the micro frontend generator, which took out the overhead of bootstrapping a brand new micro frontend. With all this, over the period of 2 years, we now have 20 micro frontends running on production as of now. There are a few which are in development mode right now, but they'll be on production soon also. But all of this sounds very happy, but of course we made a lot of mistakes along the way. Of course, we started the migration process very late. Like by the time we started to do micro frontends, our monolith was huge. So anyone who is here who can relate to these problems, and you see that these problems will occur for you in the future, this is the right time for you to consider micro frontends now. The artifact service. If you noticed, artifact service is actually a single point of failure. All the all the metadata about micro frontends are inside the artifact service. What if the artifact service goes down? If the artifact service goes down, all our micro frontends would be down, and there'll be like a global outage on Personio. Then we kept the design system, the artifact service, and various open source projects in like an open source contribution board where engineers from Personio used to contribute to these projects. But there was no consistency, no process around how updates should be pushed to this. and it kind of created a chaotic situation at the end. But we have already solved this problem. We have the product platform UI team, which owns all of these domains now. So the problem of like having this chaos around these packages is gone now. Lastly, we made all the micro frontends rely on the monolith to provide like UI components, UI theme, and the React bundle itself globally. The reason being that we didn't want to have each micro frontend bundling its own React version. So we decided that we can just use the one that the monolith frontend is using. But then it introduces different problems. Like, what if one team wants to use a certain version of React and the other one wants to already migrate to a different version, or same with any other package that is being provided by the monolith, right? So there's a long road ahead of us. We still have the monolith frontend with us, which is kind of hard to manage already. But thanks to the micro frontends that we have, if we don't have to like frequently update the monolith frontend, we avoid doing anything on the monolith frontend. But from time to time, there's just no way around, and we do have to write code here. Also, we need to still solve the problem of micro frontends relying on the monolith for common external dependencies, right? So with this, I'm going to talk about how the future of frontend at Personio would look like. I'm not going to be able to go into a lot of detail because I won't have that much time with me, but I hope that I'll be able to give you some brief idea around this. So back in 2020, we created like like a couple of teams of engineers, one focusing on front end, one focusing on back end, on how the ultimate architecture vision should look like. And this is what we came up with. At the very top, very bottom, we have the infrastructure layer. Then we have a platform layer over it, which is also backend heavy. Then we have the application layer with an overlap of backend and frontend. This will be the layer which will contain all the microservices. It will contain an API gateway, which will be interacting with the web. And then on the frontend layer, we'll have the web layer, of course, the mobile app layer, and several public APIs. For this presentation itself, I'm going to focus on this web layer, right? So we created this architecture, and then the front end team, which was part of this bigger team, we started thinking about how this web layer would look like. Now, there were multiple components that we decided to introduce to this web layer, but I'm just going to talk about one component, which is like the most powerful engine for future of front end at Personio. We call this the layout service. What is the layout service? The layout service is basically a universally rendered React application. So if you all are not familiar with what a universally rendered application means, basically you can divide your code in three ways. Like one way could be, you can say that, hey, I want this piece of code to run only on the backend side. All right. So imagine that this is a Node.js service, and you can have some code which would run only on the backend side. You can have some piece of code which you can say that, hey, I want this piece of code to run only on the client side. So it won't be executed on the Node.js server. It will get executed on the browser itself. And thirdly and lastly, you can have a combination of these. You can say that this piece of code, I want this to be executed on the server side and also on the client side. Basically, there are like many frameworks which are providing this. I can give you one example. Like there's this framework called Next.js, which is already doing this, and probably the top contender for us also, if you want to pull this off. Now, what will this layout server consist? It'll be having the skeleton of the page. Like imagine a typical web page having a top bar, sidebar, a few more things, but we don't need to talk about that in this presentation. But basically, it'll have the skeleton of the whole web page within itself, right? Then it'll also have some API gateway interaction within itself, because in order to render content inside the top bar and the sidebar, you might need to have some interaction with the API gateway on the server side itself. Then it'll have some orchestrators. Now, this is a new term, and I'm going to come back to this just in a few minutes. Lastly, we imagine that we'll have another component called front-end core, which will basically consist of all the third-party dependencies, which are common across all the micro frontends. This won't be a part of the layout service itself. We imagine this as something independent, but during runtime, it will be somehow included in the layout service itself before everything goes to the browser. Right? Now, how would this look like on the browser? Like, how does this all stitch up together? So, for rendering a page, the layout service would be responsible for rendering the top bar and the sidebar, let's say server side, right? Uh, at the center of all this, we'll have this front-end core core package, which will in turn empower all the micro frontends on that page. Let's say that we have 4 micro frontends running over here. All these micro frontends will rely on this front-end core package for whatever is reusable across all the micro frontends. Right. Now, I talked about orchestrators, and I said that I'll get back to that later. This is the perfect time to talk about orchestrators. So if you see here, we have different micro frontends, but we didn't actually talk about how would we figure out where to mount a micro frontend. In which portion should the micro frontend go to? So this will be the job which will go to the orchestrators. They will basically have mounting points, like some kind of layout for the main content of the page. It will contain like mounting points for each micro frontend, so that you know how or like where to render a particular micro frontend on that page. Cool. So this is the only one component that I wanted to focus on in terms of the future of front end at Personio. Now, with this in mind, this is how the web front end layer would look like. Like at the top, you would have the user agent, right? Uh, the next component in this diagram would be the layout service. The user agent would be interacting with the layout service, not with the monolith anymore. Now, the layout service will have orchestrators within itself, and we imagine that for each team, we'll have a different orchestrator where each team can push their own like layout of the content, define mounting points, and stuff like that. And then at the very bottom, we'll also have the artifact service. We also have a potential solution of removing the artifact service. I'll get to that in just a minute. Of course, we'll also have the API gateway, which we'll be interacting with throughout the lifecycle of the project. Now, this is how the interaction of these components would look like. The user agent and the layout service would be interacting with the API gateway, right? The layout service would be interacting with orchestrators, and these orchestrators will be responsible for getting the asset identifiers of each micro frontend from the artifact service. Now, I said that there's a potential solution that we have here to get rid of the artifact service itself. What I mean by that is that as this whole concept grows and we realize that now the orchestrators are big enough that they can be carved out into a separate service and put outside of the layout service, we can also utilize that period of time to make these orchestrators behave like individual artifact services. You can imagine that for a particular micro frontend during the deployment pipeline, they can just ping the orchestrator, tell them about the asset identifiers, and now orchestrator would know what is the asset identifier for the micro frontends that I'm supposed to render. With this, we would remove the single point of failure which we have right now with the artifact service. All right, so this is all I wanted to cover on the future of front-end at Personio, and this also brings me to the end of the talk. If you're hungry for more, please feel free to go through these links. These are basically like similar kind of stories from other tech giants around the globe, and to be honest, these were like huge influence on us when we started doing micro frontends, and especially when we started doing the strategy of how the future of micro frontends would look like, and how will we break down the monolith micro frontends into separate micro frontends, and how will be the layout service become like the front of Personio application and not the monolith. And with that, I come to the end. Thank you everyone again for listening to the presentation. And thank you.